inequality, it's the null hypothesis.
Yep.
Yes.
Okay. And then that's where I haven't gotten the question. So the p-value is the probability of obtaining a simple statistic at least as extreme as the one that was actually information in question 5. Computing this probability, which hypothesis do you assume to be true?
I said the null again.
Yeah, that's it. Yeah, you're right, Nicholas. That's what I think it is too. Okay, everyone good on that one? So for 6, which of the following represents the alternative hypothesis for a two-failed test when U equals 10?
Is the one with the equal with the slash through it?
Yeah, like the mean does not equal 10.
Yeah.
Yeah.
Okay.
There's a little secret passage.
And why is that again? That's not equal to it? Because it says the null is, so the null equals it, and then the alternative doesn't equal it.
Yeah.
Yeah, the alternative can either be not equal to, smaller than, or less than, or greater than.
Okay, cool. 7, which of the following represents the alternative hypothesis?
Have the not equal to sign, or the greater than sign, or less than sign. And then, like you guys said, the null hypothesis is always equal to. So,
Okay.
you guys are right on the money.
Okay. 7, which of the following represents the alternative hypothesis for a left-tailed test?
I had the less than.
That's what I got too.
Okay.
Okay. So that's the one that's greater than to the less, right?
It's like to the use. Yeah.
So it's like U is less than 10?
Yeah.
Okay.
Yeah, it's the first one. Yeah.
Okay. Sounds good. Which of the following represents the alternative hypothesis for right-tailed? So it's just the opposite. So it's U is greater than 10.
Yeah.
Okay.
Awesome.
That's pretty easy.
Yeah, I like this.
Yeah.
Yeah.
And then Tuesday is going to be hard. Watch. Okay, 9. Which relationship would result in failing to reject the null hypothesis?
So I had the first one, the p-value is greater than, but not exactly sure.
I don't know on this one.
Let me look it up real fast.
I looked at the homework and that's what it said. See if I could find it.
Yeah, I love how in the wiki it says if P is low, reject the null. And so if P is lower than A, then you'll reject the null. And then, like you said, it was Sarah, right? That if the p-value is greater than A, then, like you said, you'd fail to reject the null.
Oh,
okay. So that means on the next round, then it's the other way around.
Mm-hmm.
So, like, for the next, so to reject it, the p-value is less than.
Yeah, right on.
Wait, say that again. So
Okay.
for 9,
Awesome.
So since it's to reject the null, then it's the p-value is less than A? I mean, the alpha?
Greater.
Greater, okay. So then when it
Greater
is
than.
greater than, so when it's rejected, it's less than.
Right? That's what I had.
Okay.
So we have the answer is the p-value is greater than A.
For 9, and then for 10, 9. The p is less than A.
Oh, okay.
I don't know why they put Z in there. Does Z have nothing to do with it?
Yeah, nothing to do with it.
Just, I don't know why I put that in there.
Yeah.
Okay, an insurance company is reviewing the current policy rate. When originally setting the rates, they believed that the average claim about was 1,500 there. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate? Would be the appropriate alternate hypothesis?
I said the average claim amount is greater than 1,500. Because that's what it says they were trying to prove. And then the null, I think, would be that it's equal. But
Nicholas just said the average claim amount is higher than the 1,500 because it's basically saying the same thing.
yeah, that's what I had.
Oh, okay.
Awesome.
So then it would be appropriate. Wouldn't it be equal to 1,500?
For the 12.
For the null.
Yeah,
Okay. Okay, the insurance company randomly selects n equals 40 claims and calculates the sample mean of 1650. Okay, the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yes, because it's greater than like 30, or it's a higher number.
Yeah, because the sample mean's higher than the 1,500.
Yeah.
Okay. Though the theorem of law justifies the answer in the previous question.
It's central limit.
Oh yeah, because if it goes higher, then it equals to be normal.
Yeah.
Which of the following is the test statistic as defined in this lesson?
I had Z.
Why did we get Z?
10 minutes.
Sorry, 2 minutes.
Awesome.
Then he gave him 20. We'll open up your last card.
Okay.
The historical mean of sales represents at a grocery store is 150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. So what is the z-score associated with this test?
That's as far as I got. I couldn't get these.
Do you guys remember the z-score formula?
Yeah, is it? Oh shoot, what is it again?
Is it the same as last unit?
Mm-hmm.
Yeah.
With the
Okay.
square root or not the square root?
Yeah, so anytime there's a sample size, then you'll always use the
Oh, okay.
sigma divided by the square root of n.
Okay.
Yeah, good question.
Okay.
So
One.
what I don't understand is for the top part of the equation, what do we put in? Because it's like less than 150 minus 150, or how does that work?
So for the z-score, you'll always take your x bar, and then you'll do x bar minus mu, and then you'll divide that by sigma divided by the square root of n. So,
I see x. I didn't see x bar there. Okay,
Okay.
got it.
You
Thank
get
you.
144 minus 150 over 40 square root of 36?
Uh-huh.
Okay.
I love that we could just do that in Excel now. I just figured that out. It's just so great.
You do what?
That's awesome.
So like I did the mini lesson that he did, and I just set up the equation, so you just put in the numbers, and it's so cool.
Oh, I need to learn how to do that.
Yeah, it's way easier.
What mini lesson was that underneath?
I just thought on like where he shares on the YouTube page, there's like a Excel mini lesson that he did, so I just clicked on it.
Okay, yeah, I should do that.
All right, and I have just a couple more minutes, and then I have another meeting, so I'm going to leave a little bit early, but probably like another couple of minutes. Sorry about that.
Oh, you're fine. So is it negative 0.9?
That's what
That's what I got.
Okay.
The
Awesome.
900.
Yeah.
Yeah, nice call.
But okay, so what is the p-value associated with from the previous problem?
But I don't know what that is. Is that the
Okay, so
area?
the
We just put it in the
p-value.
bracket?
Yeah. Yeah, exactly.
Okay.
Oh, that's the same thing as
Mhm.
the area?
Yeah.
Oh, okay.
It just has.
Where's that question you're thinking?
It's out there somewhere.
There's instances one too,
I
right?
know, yeah, it's out there somewhere. I don't know where.
Oh, 0.368 you guys got?
Yep.
Okay, and have you guys been shading the on
Oh,
which side of the thing have you guys been shading?
Oh, I didn't.
Oh, I didn't either. I just had the other.
Um,
Yeah, how do we do that with this one?
Okay, so you've got when the alternative hypothesis is not equal to 150, then you'll shade on both sides of the tail. And then if it's less than, you'll shade on the left side of the tail, and if it's greater than, you'll shade on the right side, on the right tail.
okay, so it's the two opposite sides, right?
Well, there's
Or
an
is it the
equal to
left
and
one?
the.
Great.
So
it's
our
the left
alternative
tail, so it's the
hypothesis
left
is it?
tail.
Yeah.
The left one. Okay.
Right on.
So it's 0.184.
Perfect.
Awesome. That's not too bad.
I got 0.186.
Oh, did you have 0.900?
Oh, I didn't put that in. Okay. Yeah, I did. I did 0 for the z-score is 0.900, and then I did the middle, and then the left one, and then I got 0.816. What did you do, Katie?
I just highlighted the left tail. I didn't highlight the middle at all.
Oh, okay, then never mind. Okay, I see.
Awesome.
Do you get 184 if you just do the left one?
Yeah.
Okay.
All right, and I've got to go, but if you guys have any questions, feel free to just send me an email or on Friday if you guys want to meet and have like a Google Hangout, just let me know. So,
Okay.
you guys are awesome. Thanks for letting me join in.
Thank you. Appreciate it.
Thanks.
Have an awesome night. Bye.
Bye. Okay, so what inference, sorry, think about the null hypothesis for this problem?
Rejected if you're.
Yeah, because we're doing the,
I think so, because there's a big difference.
okay.
But
Wait, so what are we saying?
I would say reject.
Okay,
Right.
and how do you know?
I just thought it was because there's a pretty big difference. Because in the examples, it was like 0.0000 something was different. But this one, there's a pretty big gap.
Oh, and like this level of significance is 0.05. So if it's like above that, then maybe.
Well, it says we reject it. So it says if we gather enough evidence against the null hypothesis and determine that it should be rejected, we need another hypothesis to propose it. So we did the adjacent one, right?
Uh-huh.
Hypothesis. So then we rejected the null.
Yeah.
Okay.
Okay.
I
Cool.
think that's it.
So we put. Okay. So the answer is fail to reject the null hypothesis, or reject the null hypothesis.
Reject.
Reject.
Okay. I think I put the second one. Okay, got it.
So there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Let me check.
Type 1 error.
Oh, yeah. And there was like
Okay.
some acronym he used in the
Yeah, it's
video that was really helpful.
It's type 1. Right.
Okay.
Okay,
Awesome.
so as a researcher decides that instead of using a level of significance, alpha is 0.05, when he will use alpha 0.01, which is following as true.
Not too good. I don't know if it's type 1 or type 2.
Yeah.
I don't think it's the third one because it's making it bigger.
Well, so the null hypothesis is the first one, alpha 0.05.
Yeah. Yeah.
So then he will use less than that. So, I don't know. Because type 1 is committed when we reject a null hypothesis that is true. A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true.
So I don't think it's either of those, is it? Because it has to do with something else.
And then it says the
Oh, I'm not
value
sure.
of A is the probability of committing a type 1 error. Dang it, why did she have to get off? Why did the TA have to get off?
At this time,
Yeah.
yeah. Just two
These are
more.
the only ones that we really need help on. I'm wondering if it will be more scientifically valid because it's less.
Was there a problem like that? Was there a problem like that on the preparation?
I don't remember anything like that.
Right there at the end. Alright, I'm just gonna look real quick.
Like valid saying that like his is better because like I don't really know.
Wait, the value of A is the probability of committing a type 1 error. So I think it's less likely that we'll commit an error. So that's not right.
Yeah.
Okay.
So should we just say it was more scientifically valid?
I would assume.
Okay.
Sure.
Or, okay.
Okay, so we're good on that one, right?
I think
Yeah.
so.
Okay, so if F alpha 0.05 compute the probability of committing type 1 error. What is it asking?
I have no idea.
So if we reject it when it's true, but I don't know. Oh man, I have no idea.
Yes, is it asking a number or is it asking if we say if it's?
I think it's a number because it's a probability.
Yeah.
Oh, so is it 0.05? Is it 0.95?
Is it the opposite of what we had at the beginning?
Maybe.
You know what? Let's go for it because it's my son's birthday and I gotta go. So.
Oh, sorry.
Oh, you're fine.
Yeah.
I'm gonna go.
Okay, what are we gonna say?
0.95. Let's just say that.
Okay.
0.95. Okay.
Submit
I'm gonna submit.
it. Yeah, we got it wrong.
Oh, okay. Well, we can ask and figure that one out.
Yeah. Okay, thanks guys
Yeah.
I'll post the link.
Thank you.
Thanks. Bye.
Bye.
Thanks. Bye.